Mensuration Mobile, quality e-learning experience on the go.
Good day, my name is Balaji. You are welcome to Fusion Mobile e-learning class. I want to talk on the subject mathematics, and the topic is mensuration of solid shapes. Mensuration of solid shape. There are different kinds of shapes that we will know. We have triangle, we have quadrilaterals, we have other shapes, we have spheres, we have circle. But today I want to center on the sphere. I want to center on the sphere. There are formulas for finding the sphere. There are formulas for finding the sphere. Their area, their volume must be put into recognitions. Now let us go on to the formula of sphere. Now we are going to consider one, area of this solid shape. Two, volume of this solid shape. These are the things we are going to be considering in this topic today. Now, what do we mean by volume? Volume is the space occupied by any given solid. Volume is the space occupied by any given solid. We all remember what it means by matter. One of the characteristics of matter is that it has volume, it occupies space. So volume is defined as the space occupied by any given solids. Now, I want us to consider sphere, as I've said earlier on. Example. A sphere has a radius of 8 centimeters. A sphere has a radius of 8 centimeters. Find the surface area. Find the surface area. How do we find the surface area of a sphere? I want to show you the shape of a sphere. A sphere has 8 centimeters as its radius. Now this is the radius of a sphere. Now they now ask us to find the area. The area of a sphere is calculated to be surface area is equal to 4 pi r square. This is the surface area of a sphere. 4 pi r square. Now, solution. If the surface area is 4 pi r square and the radius has been given, our radius is equal to 8 centimeters. Our pi is equal to 22/7. Then our SA, which is the surface area, is question mark. Therefore, our surface area SA is equal to 4 times 22/7 times 8 squared. This is the formula for the surface area that I've given you. We substitute our value. Remember, pi is 22/7 or 3.142. Therefore, our surface area is equal to 4 times 8 squared times 22/7. And the answer is equal to 88 times 64/7, which is equal to 804.57 centimeter square. 804.57 centimeter square. The surface area of this sphere is 804.5 centimeter square. How do we find area? We all remember back in the days in our junior secondary school that area is calibrated in square centimeter, and that is what we have gotten to be 804.57 square centimeter. That is our surface area of a sphere. I want you to understand that this sphere can also be cut. What do I mean? We might not have a full surface area of a sphere, and that is what is result into what is called hemisphere. Hemisphere is different from sphere. We cut hemisphere, the surface area, into two. So we call it hemisphere. We cut sphere or the surface area of hemisphere into two and result into what is called hemisphere. So the surface area of hemisphere is different from the surface area of a sphere. We all know the baseball that we use in our games in lawn tennis is an example of a sphere. The shape of that baseball is spherical in shape. We all know that the shape of the heart is spherical in shape. Therefore, we can calculate the volume of a sphere also by using our formula. The volume of a sphere is also calculated. But before I go to the volume of a sphere, let us consider the shape of hemisphere. Let me show you the shape of hemisphere. This is the shape of hemisphere. It's an example of a solid figure, a solid shape, which we have to understand very well. There are differences between a sphere. This is a sphere. This is hemisphere. This is sphere. We know that the surface area of hemisphere is given to be 4 pi r squared. Now we have the surface area of hemisphere, which is different from the sphere. The surface area of hemisphere is given to be 2 pi r squared, because I told you that we divide the sphere into two. Surface area is equal to 2 pi r squared. So the difference between sphere and hemisphere is that you divide this into two. You get 2 pi r squared for the surface area of hemisphere, and for the surface area of sphere we have 4 pi r squared. I'll give example on hemisphere so that you know that there is difference between hemisphere in terms of their calculations. Hemisphere. Example 1 on hemisphere. A hemisphere has a radius of 9 centimeters. Calculate its curved surface area. Calculate its curved surface area. Now, we know that the surface area of hemisphere is 2 pi r squared, but when they mention curved surface area, the curved surface area is different from surface area. That is one thing I want to chip in here today. Curved surface area. Curved surface area. The curved surface area is equal to surface area plus area of the lid plus area of the lid. Now, what do I mean by the surface area? We all know that the surface area of hemisphere is equal to 2 pi r squared. Now, that's the surface area of hemisphere. But the curved surface area is equal to this SA plus the area of the lid. What do I mean? Look at the diagram above. This is the hemisphere. We have here radius. Now, this is the curved surface area. The curved surface area is different from the area of the lid. The area of the lid, we all know, that's the area of a circle. Area of the lid is the area of this circle is equal to pi r squared. So if this is equal to pi r squared, then the curved surface area is equal to 2 pi r squared plus pi r squared, which will give us 3 pi r squared. So curved surface area is different from surface area. The surface area I've told you is 2 pi r squared, and the area of the lid, that is the area of a circle, because when you look at it, we have the area of this circle here to be pi r squared, and the curved surface area of this hemisphere is 2 pi r squared plus pi r squared, which will give us 3 pi r squared. So 3 pi r squared is the curved surface area of hemisphere. I will give you example on this curved surface area of hemisphere. Now we have known the formula. Hemisphere. We have curved surface area of hemisphere is equal, the curved surface area of hemisphere is equal to 3 pi r squared. The surface area of hemisphere is equal to 2 pi r squared. So now, curved surface area and surface area of hemisphere and surface area of hemisphere are different. We have 3 pi r squared, and then the surface area is 2 pi r squared. So please don't make mistake by putting the curved surface area of hemisphere and exchanging with the surface area of either sphere or other shapes. Now let us consider this example. Find the surface area of a sphere. Find the surface area of a sphere whose diameter is 42 centimeter. Find the surface area of sphere whose diameter is 42 centimeter. Now, I want us to still understand the surface area of sphere once more. Now, diameter is equal to 2r. That is, when you multiply 2 times radius, will give you diameter, and our radius is equal to diameter over 2. What do I mean by this? From here to here is our diameter, and when you divide it by 2, you find out that this is 1 radius, this is 1 radius. So divide diameter into 2, you have 2 radius in this aspect. Now, 2 radii for my, okay. You have 2 radii, 2 radii. Then we have 42 centimeter as our diameter. Now, to find our radius, r is equal to 42 divided by 2, which will give us 21 centimeter. So we've gotten our radius easily by finding the radius. Now, how do we now find the surface area of a sphere? I told you earlier on that the surface area of a sphere is given to be 4 pi r squared. Our pi is equal to 22 over 7. Our r now is 21 centimeter. Let us substitute our value to find our surface area of a sphere. Now, 4 times pi, 22 over 7, times 21 squared. Our answer to the surface area of this sphere is given to be 4 times 21 times 3 times 21, which will give us 5544 square centimeter. That's the answer for this equation, that is, find the surface area of sphere whose diameter is 42 centimeter. 42 centimeter. So in a case whereby they gave us diameter, they did not give us radius, we have to find our radius. Now let us proceed by showing you a few things about this hemisphere I said earlier. Please don't be confused about this equation. Hemisphere is different from sphere in terms of their calculation, in terms of their area, in terms of their volume. Now let us proceed by showing you a clue about these questions. Now, a hemisphere has a radius of 9 centimeters. Calculate 1, its curved surface area. 2, calculate the total surface area. 3, calculate the volume of the hemisphere. Now, example 1. A hemisphere has a radius of 9 centimeters. A, calculate curved surface area. Curved surface area. That's 1. 2, total surface area. Then 3. Okay, before then, I would like us to just stop at this place to calculate the curved surface area and total surface area. Please, I don't want you to be confused about curved surface area and total surface area. You can find surface area and total surface area. They are different. Curved surface area is different from total surface area. Now, we are being given radius to be 9 centimeters. Our pi to be 22/7. Please pardon me by saying this, that curved surface area is equal to, the curved surface area is equal to 4 pi r square divided by 2, which will give us 2 pi r square. That's curved surface area of hemisphere. Our total surface area is given to be curved surface area plus area of the lid, which is equal to 2 pi r square plus pi r square, which will give us 3 pi r square. So 3 pi r square in the total surface area, while the curved surface area is 2 pi r square. Therefore, let us substitute our value where we have radius of 9 centimeters. We have our radius to be 9 centimeters. The curved surface area is equal to 2 times 22/7 times 9 square. That's the curved surface area, which will give us 44/7 times, what is 9 square? 81. Which will now give us 44 times 81 divided by 7. 44 times 81 divided by 7. And the answer is equal to 509.17 square centimeter. So the core surface area of a hemisphere in these questions having a radius of 9 centimeter is 509.17 square centimeter. Please don't be confused about this formula. There are plenty. We have many of the formula of different shapes. Core surface area is different from total surface area. Surface area is different from total surface area of any shape. Considering this hemisphere that I have drew earlier on, difference between sphere and hemisphere, the core surface area is this, while the total surface area is this. The total surface area is different from the surface area, and the core surface area is different from the surface area of any shape. And we have unraveled it correctly here. Therefore, how do we calculate volume of hemisphere? Inside the sphere is called a container. That is, we said earlier on that volume is defined as occupy, that is a solid that occupy a certain space, because volume is one of the characteristics of a matter. Matter exhibits volume. So therefore a solid shape can have volume. A solid shape can have volume. Before I proceed, I'm convinced that you understood the difference between total surface area and core surface area, between sphere and hemisphere. I would like you to do these few evaluations so as to know how far we have gone. Wow, thank you. I know you've understood this topic, mensuration of solid shape, taking sphere as one of our priority, and we've deciphered how to calculate their total surface area and their surface area. Also, I want us to proceed by finding the volume of a sphere and hemisphere. Volume of a sphere and hemisphere. Volume of a sphere and hemisphere. Volume of solid shape sphere. Now, how do we find the volume of a sphere? The volume of a sphere, we all remember that volume is measured or calibrated as area times what? Times length. Area times length. Area times length will give us the volume of any shape. Now, how do we find the volume of a solid shape of a sphere? How do we find it? There are a formula for it. Volume of sphere is given to be 4/3 pi r cube. 4/3 pi r cube is the formula for finding the volume of a sphere. Is the formula for finding the volume of a sphere. Let me give you one example so that we can solve it. Find example 1 on volume. Find the volume of a sphere whose radius is 8 centimeter. Earlier on, we saw the surface area of a sphere having a radius of 8 centimeter. We likely want to solve the volume of a sphere that have 8 centimeter as a radius to know how space it occupies. How many space, what is the measurement, what is the quantity of the space a sphere occupies? Because every shape, every plane figure has their formula for finding their volume. So we want to know the volume of this sphere that have a radius of 8 centimeter. Solution to it is that the volume of sphere is equal to 4 over 3 pi r cube. Our r is 8 centimeter. Remember, our pi is always given to be 22 over 7 or 3.142. Therefore, the volume of sphere is given to be 4 over 3 times 22 over 7 times 8 cube times 8 cube. Therefore, 4 times 22 times 8 times 8 times 8 over 7 times 3. That is the volume. Now the answer to this is 450.56 over 21, which is equal to 2145.52 cubic centimeter. Cubic centimeter. The answer to it is 2145.52 cubic centimeter. That is the volume of a sphere. Cubic centimeter. Remember, there is difference between volume and sphere in their units. So don't let us make mistake by putting centimeter square. This is cubic centimeter for volume of a sphere. I'm convinced that you understood difference between volume of sphere and area of a sphere. I would like you to do these few evaluations so as for you to know how far we have gone. Good. I want us to consider the volume of hemisphere. Volume of hemisphere now. Volume of hemisphere. Hemisphere is different from sphere. The volume occupied by hemisphere is different from the volume occupied by sphere. The volume of hemisphere is measured to be volume of hemisphere is given to be 2 over 3 pi r cube. 2 over 3 pi r cube. How do we get 2 over 3 pi r cube? I told you that before we can get hemisphere is the half of sphere. So the volume of sphere is 4 over 3 pi r cube, while the volume of hemisphere is 2 over 3 pi r cube. That is the formula. Therefore, I want us to use this example. Example 1. A hemisphere whose radius is 9 centimeter. Calculate its volume. Now, we have radius to be 9 centimeter. They ask us to calculate the volume. Our radius is 9 centimeter. Our pi is equal to 22 over 7. Then, our volume is equal to question mark. Therefore, for us to calculate the volume, which is equal to 2 over 3 pi r cube, is equal to 2 over 3 times 22 over 7 times 8 cube, which is equal to 44 times 9 cube times 9 times 9 times 9 over 3 times 7, which is equal to 44 times 9 times 9 times 9 over 21. And the answer is equal to 1527.4 cubic centimeter. Now, I'd like us to see that there is difference between hemisphere and sphere. This is the volume for calculating hemisphere. We substitute our value whose radius is 9 centimeters. I want us to remember this. If we're being given a diameter, divide your diameter by 2 to get the radius of the hemisphere. Now, to find the radius of a hemisphere is that if you're being given a diameter, you have to divide the diameter by 2 to get the radius. By the time we divide the diameter by 2, then we get our radius, then we substitute our value into it. By this, I am confident that you can solve questions on this solid sphere. The difference in their core surface area, in their total surface area, and in their volume. Remember, the surface area of a hemisphere is different from the surface area of a sphere. The core surface area of hemisphere is different from the core surface area of sphere. The volume of hemisphere is different from the volume of a sphere. Remember, the total surface area of hemisphere is given to be 2 pi r squared plus pi r squared, which will give us 3 pi r squared. The volume of a sphere is given to be 4 over 3 pi r cubed, while the volume of a hemisphere is given to be 2 over 3 pi r cubed. Please don't take hemisphere for sphere so as to know your calculation rightly and to have a good answer. By this, I'm confident that you'll be able to solve the question ahead, and I know that you will not be having shady mindset. And if you discover that you couldn't get it right, I'd like you to rewind and hear the topic very well. Thank you.